Hello everybody. So today I will talk about the system design of Uber. So obviously Uber is the app in which user can find the driver and the driver takes him to the destination and user pays for that. So I will talk about the functional requirement. So firstly, user can search the drivers. Maybe user can input the start location and destination to search the drivers. And then user should be able to see the fare estimate, like how much it will take. And then user can request the ride. So if the fare estimate looks good to him, he requests the ride. And then what happens is that he matches with the driver. But now what happens is the driver should accept the request. The driver is notified on the ride request with push notification and can accept the ride. So what I mean here is, let's say in this, design, I will make it first, match first served order. So sorry, I mean, first accept, first, yeah, match. Sorry, I mean, the driver who accepts the first is matched to the user, and I mean, there are multiple drivers who are notified on the request with push notifications. Okay. So I mean, like this. Then user matches driver. Yeah, and I mean, of course, driver should driver should be driving to the start location and picks up the user and goes to the destination. But I don't include that in the system design discussion. Okay, so these are the functional requirements. Okay, so I will talk about the non-functional requirements. So firstly, I will start with the cap theorem. So cap theorem is the characteristics of the system. So I mean, out of the strong consistency, availability, and partition tolerance, the system can meet up to 2 characters. Yeah. And because we are developing the distributed system, the partition tolerance is a must. Without the partition tolerance, the system doesn't know what it should handle when there is a connection loss. So I have to choose one out of availability or strong consistency. And basically in this comparison can be rephrased like in this case, the process which handles the user request should be able to read the latest data status, including the latest write from some other process, or maybe itself. So that's the strong consistency prioritized case. But if availability is, chosen, the process which handles the user request should be able to read the data always, even if it's a bit outdated, and maybe the latest write from some process is not reflected to that data yet. So when I think of this, I can say, so for this one, user matches driver, we need a strong consistency because let's say there is a process who tries to match the user versus the driver with the user, and it reads the kind of match status of that user. And even though it already matched with other driver, if strong consistency is not guaranteed, it cannot know, maybe it cannot know that that user has already matched because the process cannot read the latest data. So if I choose the availability for matching, this can happen. So for matching, I will take the consistency. But for other parts, eventual consistency is enough. So let's say, for example, the driver's location. It is completely fine that the driver's location is a bit outdated, like 10 or 20 seconds ago location. Even if in that case, even with that, users try to know the data up and the location data in user's app should be updated constantly. Okay, so this is the discussion about CAP theorem, and I will choose the row latency. So this is all around, let's say, fair estimate. For fair estimate, I think 3 seconds red arrows. I will be a bit, loose on this. And so matching. So this should be more, I think we can take more time on matching. Yeah, because user really wanna write the match. So system-wise, business-wise, we wouldn't, lose the user. And of course, matching is not so, easy. Yeah, because there are a few drivers. It doesn't. I mean, it takes a long time sometimes. Okay. Yeah. Okay, so for scalability, so it should be scalable to 100 million data active user. I take this number quite randomly, kind of, and 15 million writes per day. And also I will calculate this by myself later, but also it should be able to handle the spike. So in the case of Uber, the spike can occur. So let's say there was a kind of baseball game in the Dodgers Stadium, and after the Dodgers Stadium match, maybe there's many users who'd like to take the Uber to go home, especially when after they drank a lot. So in that case, in the specific area, segment, there are so many users, maybe 10,000, 20,000 users makes the request, makes a search at the same time. So this is a spike which occurs in this kind of Uber system design. Okay. Okay, so I will now do the kind of core entities. I will talk about core entities. So this is a core entities are the name of the database tables, basically. So I will list what kind of models we need, and yeah. But for attribute, I don't talk about them for now. I will talk about them later. So of course we need the user and driver, or maybe you should say rider, driver. Of course, it's a kind of design if we should create user table, and that user should be work as maybe a user can work as rider and both also driver. So it's a kind of design I have to take care. But for this one, I will create two models, rider and driver. Yeah. Okay. And we need the location of the driver and the user, rider, and sorry, let's say user and driver, because yeah, basically when we say user, it's a rider who pays money and receives the service. So user and driver and location, and what else? Ride. Okay, maybe location, destination, fare estimate, and request and match. Okay. Yeah. Maybe I should say, so when fare estimate is created, request is made on that fare estimate, and then matches fare estimate may end up as the match or not. But for here, I will create different entities. Yeah. Because I don't want to make this table so huge, like it has the request information or the request timestamp or request result. I mean matching, match or not or something like that. So I separate these. Okay. So let me rename this match to right. Yeah, because after matching, there's so many things happens in the right. I mean, like when the user, sorry, driver arrives the destination or something like that. How much tip user paid. So I will make it right. Okay. So I will talk about the API design. So I will think which APIs are needed. So firstly, a user should input start location and destination and search drivers. So I would say search drivers. So which should return fare estimate. And then user sees the fare estimate and user can request the ride. So yeah, request ride. So this should return. Okay, this is something I have to be careful. So when the request is made, maybe I should say make request. So I mean, it can take up to 1 minute. So, and I'm pretty sure I shouldn't keep the HTTP request here, because if I do that, there are higher probability that there is a network connection loss between server and client, and it messes up the server side state. So rather than that, I will use the polling here. So in the first request, you know, client requests a server side that to make the request, and then this should return nothing. Yeah, with just with success state in Habib case, and then we need the short polling API. So fetch result. So this should return the result, maybe including the match. Okay, I will write the detail later. For now, I will list the name of the APIs. So this is a short polling API. Okay, and drivers notified on the right request push. So I need something like drivers API. So driver is notified about the push request. Sorry, write request and push notification. That's fine. Then he has to send the result. So like accept or not. So what should I say? Yeah, I would call it accept request. Maybe answer request API. So this should return nothing. Or I should say the result, match or not. Then what can I do? And user match driver, yeah, this is done with this fetch result. And one more thing, driver has to update the current location. So I will, and this should return nothing. Yeah. And of course, we need the user to fetch the current location of the driver, but I don't include it because in this design, I will talk until the matching. Okay, so in detail, for search drivers, I would say post request search, or I should say fair estimate. And because this request should needs the authentication, I include the session token in the header. This includes the user ID, and we need the start location and destination, and we return the fair estimate, the list of fair estimate, which should be rendered in the front end. Okay, and then make request. So user decides to make the request for one of them, one of the fair estimate. So I would say I think this should be put request. Let me think. Oh, sorry. So I would use the post request because put request, if I use the put request, it means that if many users makes the same request for the same request ID, that match is updated every time, or I should say replaced by the latest request, because put is the idempotent one. Obviously, this is not something we expect. Rather than that, as an image, the match should be created for each request only once. So I use the post request here. Okay, and update location. So here I can use the put request because locations for of that user should be updated with the latest one. Or I should say replaced with the location in the latest request. So yeah, this one. Okay, so these are APIs I will implement. Okay, so I will do the high-level design from here. So, okay, so in this high-level design, I will try to satisfy all the function requirement, but not the non-function requirement yet. Okay, so I will implement all the APIs I've listed here. With that, function requirements are met. But of course, the quality of the service is not guaranteed yet. With that, so I will talk about them later. So firstly, I can say there are two users here, user and driver. Yeah. And I will talk about the first API first, so which is the create fair estimate API. So I will use the microservice design here. So we put the API gateway. The reason why I use the microservice architecture is that in the end, this system has to scale to many users. So I use the microservice so that as the organization, engineers can be, how should I say, team of the engineers is responsible for specific domain. So in that way, the separation of the domain in the service system and also in the team is very clear. And also in terms of the fault tolerance, even if the matching feature goes down because some problem, we wanna keep working. We want the ride which is going on to keep working. So for drivers, he needs to know the destination constantly, the route to the destination constantly, so that feature should not die even if much feature dies. So I use the microservice architecture so that the failure in the specific domain doesn't affect other features. Okay, so first API, create fair estimate. Okay, so maybe I should start with the actually update location because this location is used for anything, everything. Yeah. So I create the location service here. And the user makes the request to API gateway, and the request is routed into the location service. So this API gateway does the routing and also authentication and also sometimes rate limiting for malicious users. And also driver makes the request to update location. So now this location service persists the location data in the database. So let's say I use the Redis geohash for now. I will discuss what data, what database I should use later. Oh, sorry, maybe I will make it just something. Yeah. So this is the location. Okay. I will talk about this later, but the requirement of this database is to handle the location, kind of geolocation query. So probably geospatial index is needed. So we need, this has the location table, which has the user ID and longitude, latitude, and update. Okay, so this is the location DB. Okay, now I've implemented the update locations, so I will go with the create fair estimate. So user makes a create fair estimate API, And let's say this is sent to the right service. So this is about the create fair estimate API. So now this right service creates the fair estimate recode in the database. But of course, this fair estimate generation needs a kind of algorithm like machine learning or something like that. So I will make it a kind of brown, black box here. We have the fair estimate service here. So write service now makes a request to get the fair estimate and return it to the user. But of course, this write service should keep it in the database because it should be referenced later. Yeah, of course, this write service can make the request to fair estimate every time to get the reference, but because fair estimate is not updated, basically, so I will persist it in the write service in the database. So create fair estimate recode. So I will call this write db and I will use PostgreSQL here. I will update this if there are some requirements which needs some other database, but for now I will go with the standard. So we need the fair estimate table, which should have the ID and of course user ID who requested it and start location and destination. Maybe this should be longitude, latitude. Yeah, definitely. Yeah. I put them in the one column, but probably we need maybe longitude, latitude for in each column. Yeah, and maybe request. Maybe request is not good. Yeah, just user ID. Okay, and create it. As I said, multiple fair estimated created for user, and user receives the fair estimate list of them, and they are rendered in the front end. So now first API is implemented. So I will talk about the second API, which is make request API. So based on the fair estimate chosen by the user, this sends the make request API. So this make request API is routed into the write service again. And this create the request recode. So we need ID, goes for estimate ID. It is expected that user ID who requests should be same as fair estimate. Create user ID, maybe we can put the validation here in write service, but anyway, user ID, fair estimate ID, and what else? Created that. Yeah. So this is a request. And of course, request has a status which should be updated. So this should be either of created or matched. Should say matching, matched, or not found. Okay. So firstly, when create request is created, it starts with matching status. Okay. Now request ID is returned to the user. And the user makes a polling to get the request status. Yeah, but who updates this status? Obviously, a driver's request triggers the update of the status. But what triggers the driver's answer request? It is the push notification. So when the request record is created, the system has to find the driver who'd like to match. So I will use a change data capture and worker driver here. Sorry, worker service here. Yeah, so I should say I use the worker named request worker. Yeah. So this request worker reads the request data created from the change data capture. And this request worker decides which driver it should request. So probably, yeah, obviously request worker reads the location data of the requester user and drivers around him. Yeah. And of course, change data capture. Yeah, okay. So then request worker decides the drivers to make the kind of match request. So now internally in our service, we should have the notification service. So this request worker makes the request. And this notification service should send the request to third party push notification service. So in case of the for the Android users, we need the Google Firebase messaging API, and for the iPhone users, we need Apple push notifications API. So notification service makes a request to this third-party API, and then this should send the request to the match request to driver. Okay. Now this driver user makes the request of driver answer request. And actually this should be stored in the database. Later, of course, we need kind of analysis. So sorry. So I put the kind of driver response table. The response is accepted or not. Yeah. So now for this request, create driver response recode. And also we need the match recode if they match, and also we have to update create update request match service status 2. Okay, so this is it. So yeah, so we need the match recode. So this should be user ID, driver ID. And of course, this match record should have some more information, like when the driver arrived as the meeting up point or something like that. But I don't talk about them in this video. Okay, so yeah. Let me quickly read. Let me quickly dry run each API request. So for create fair estimate, user makes a request and write service makes the internal microservice to get the fair estimates and then persist it in the fair estimate table. Yeah, and that's it. It is returned to the user, and user now choose one of them and makes the request API. And for this request, makes the request API call. And request API call request is handled by write service, and write service now creates the request record in the database with status matching. Yeah, and this request creation is consumed by the request worker as a change data capture, and now this reads the location of the user and driver. User, requester user, and the drivers nearby. And for those users, request worker would like to push a notification. So it calls the internal notification service, and notification service sends the push notification to the drivers through the third-party push notification APIs. And now driver looks at the, write request from the user and answers it. So the answer request is routed into the write service, and write service creates the write response record and also creates the match record if it matched. I mean, the driver is matched with the user, and also updates the request.status. Yeah. And of course, they should be done in one transaction so that the data should be consistent. Data inconsistency should not occur. Yeah. And one more thing I forgot to talk is fetch result. So this fetch result is quite simple. User makes a request to fetch result, and this reads the request dot status. Yeah, so now client can get the request status, and if it is matched, it means that the match is found. So probably, yeah, I updated this, but this matched status, if the status is matched, match ID should be returned too. So now this use client can get render the matched UI and start the delivery process. Yeah, but if not found is returned, the UI should show a kind of message that match is not found. You couldn't find the driver. And of course, if matching is returned, the UI should keep loading the waiting page and the user has to wait more. Okay, so this is a high-level design of Uber. So tomorrow I will talk about the non-functional requirement, especially strong consistency and scalability. Yeah. Okay, that being said, I finished my today's system design practice. Thank you so much. Bye.